Hey guys, today we're going to be talking about how to solve word problems. So, let's get the pen working here. We're going to be solving word problems. And consecutive integers. So we're going to give you a general strategy for solving any type of word problem. And then we're going to talk specifically about problems that involve consecutive integers. Okay? So, general strategy. And we've already kind of talked about this, but we're going to make it official for solving word problems. So I look at word problems having 4 components. First component is going to be you have an unknown, so you need to use a variable to hold its place, and you need to let somebody know what that variable represents. You're going to need to take the words that you see and change it into an equation where there's math happening to the variable, and there's an equal sign, and there's numbers. Now, sometimes you have variables on both sides. Then you're going to solve using the inverse operations to undo the maths until you get the variable alone, starting with getting the constants together, then getting the coefficients. Then you're going to check for reasonableness. Does it make sense that you could sell half a car one day? No, probably not. And then also make sure that you have a label, and then write your answer in a sentence so that it has context. So let's write all of those down. So let's start with step 1. We're going to read. I know this sounds silly, but so many people forget this part. Read to understand. A lot of people just skim, just like people do with an English book. They just kind of skim through it or use some sort of note application so that they can have somebody else read it and kind of give them the highlights. Nope, you got to read the whole thing. And how many times? I would say at least twice. Okay, first time is to get the gist. The second time is to start grabbing information out. So, what is it about? So, what is the problem about? Are we trying to figure out how much something is? Do we have to figure out how far something's traveled? Do we need to know a formula to use it, right? And then we ask, what are the facts? What are the numbers that they mentioned? Okay, but you have to be careful because sometimes the numbers that they mention aren't always part of the problem. And then, what do you use solving for? Okay, so then the second thing is going to be identifying the unknown. So identify the unknown. And I define it. So I'm solving for the cost of one movie. And so I'm going to choose a variable, and I'm going to say cost of one movie. Okay? Then we're going to get into the equation part. So we're going to translate the words into an equation. Okay, So that means I'm going to see numbers, I'm going to see variable, could be more than one. I'm going to see operations, okay, and I'm going to see an equal sign, okay. Now when we translate, we're going to be literal, okay. We're going to make sure that what we see, we're going to write down. Now the only exception is, you got to watch out for switcher phrases. Okay. Now we can go finally solve the problem. Again, using the inverse operations, not guessing what the unknown number is, we're going to solve it. No more guessing. That's a technique when you didn't have any other skills, but now you have skills. Okay. And then you're going to check for reasonableness. And label. So many people forgot labels on the test. Gotta remember those labels, super duper duper important. Okay? And then we're going to write the answer in a sentence. Okay. So now what we're going to do is talk about consecutive integers, but I'm going to do it on a new screen just so I can have room to do it. And you guys have to understand what that phrase means, consecutive integers. Okay, so first off, let's deal with consecutive. That would mean in counting order. 1, 2, 3, 2, 4, 6, 5, 7, 9. Okay, so consecutive. One number and then the next logical and so on. And what are integers? Those are going to be whole numbers and their opposites. So no fractions or decimals, but positives or negatives. Whole numbers, remember, is 0, and the counting numbers 1, 2, 3, 4, 5, 6, and so on, and their opposites. Okay? So we have 3 different ways of looking at consecutive numbers. So the first way would be just consecutive numbers. No other stipulation. So that would be things like 1, 2, 3, and so on. So what you're doing is you're going to be counting by ones, so count by ones. Okay? So that's the first grouping. The second grouping gets a little bit more intense. These would be consecutive odd integers. So that would be like 11, 13, 15. Okay? And what you're doing is you're counting by twos. Okay, so we're skip counting. And then the third group is the consecutive even integers. So that would be like 4, 6, 8, and so on. And again, you're skip counting here as well, so you're also count by twos. Okay? Now, the reason why that's important is because when you're told in a word problem that you have 3 consecutive integers, you need to know how to define those numbers. If you have 3 consecutive even integers, you need to know how to define those, okay? So let's go through those definitions. So in a word problem, we're going to go through 3 scenarios. How would we define the first number? How would we define the second number? And how would we define the third number? Now, you could have more than 3 numbers and you can have less than 3 numbers. Okay, so let's start with our consecutive. Oh, you know what? I wrote numbers there. Let's change that. That should say integers. There, that's better. And so let's start over here. Consecutive. Come on. There we go. So, what's going to be the first number? X would be the logical choice. So that's what we're going to choose. Now, going back to our numbers, 1, 2, 3, what do I do to 1 to become 2? Well, I'd add 1 to it. So if x was 1, I would have to add 1 to x to get to 2. Well, what would I add to 2 to get to 3? I'd have to add 1 more. What would I do to 1 to get to 3? I'd have to add 2. So our pattern is our first number is just the variable, and then we add 1, add 2, add 3, and so on. All right, let's talk about our consecutive odd integers. So again, just like with consecutive integers, x is going to be our first number. But now think about it. What do I do to 11 to get to 13? I have to add by 2. So the second number would be x plus 2. Well, what would I do to 11 to get to 15? Or what would I do to get from 13 to 15? I'd add another 2 onto 13, and 2 plus 2 is 4. So when I'm counting by 2's, then I'm adding another 2 to each integer. Now the interesting thing is, with consecutive even integers, we still have x as our first number, and if I go from 4 being x to 6, I need to add 2 to that number. And then if I wanted to get from 6 to 8, I'd have to add another 2, or if I wanted to go from 4 to 8, I'd have to add 4. So the pattern for defining unknowns with consecutive odd and consecutive even is always the same, because both of them count by 2's. They skip count. But with consecutive integers, then it's just counting by 1's. Now I am going to tell you the notes are going to be kind of long, not because we have so many things in here, but we actually have to write out our word problems. And that's just the way it goes. So directions are going to say, define the variable, translate an equation, then solve. Write your answer in a sentence. I want to give some context. So basically, those 4 separate directions, that's what you're getting points for. 1 point for each of those. And I've had people balk at it, but you know what? It is what it is. I'm telling you right now what I want. Allison is making, this is the longest problem we have to copy down, a stained glass window. Sounds like a fun hobby. Her pattern requires that 1/5 of the glass should be blue. She has 288 square inches of blue glass. If she intends to use all of her blue glass, how much glass will she need for the entire project? Now, if you don't think you should be writing down this word problem, you are actually, it's a detriment to you, because writing down a definition and an equation without the word problem makes no sense. So I know it's cumbersome. Just pause and write. Go forward, stop, write it, and then continue on. Okay? All right, so let's see what we have here. So let's think about what they're asking, because she's making stained glass window. Okay, she's going to be using 1/5 of the glass in the window is going to be blue. We have 288 square inches of blue glass. She's going to use all of her blue glass. How much glass will she need for the entire project? So generally speaking, the question reveals what we're solving for. So it's the amount of glass needed for the entire project. So I just basically take the words, the questions, and make it a statement. Okay, so let's see if we can find some stuff. First sentence, she's making a stained glass window. That's just giving you background. Her pattern requires that 1/5, okay, here's a number, of, that is an operation word. That one means to multiply. The glass should be blue. Okay, so then we're going to have blue glass. And then it talks to me about how much blue glass she has. Okay? So now I think I got enough here to write my equation. So 1/5 of all of the glass. So notice here, the glass. So 1/5 of, so that's going to be multiplying, right? The glass, that's our unknown, should be. Now, this is where things get a little bit strange. That doesn't say equals, but guess what? We talked about the to be verb is, was, were, let's see, should, shall, will, so on and so forth. Those all are to be verbs. They take the place of the equal sign. Okay. So if 1/5 of all the glass is her blue glass, and she has 288 pieces of blue glass, or square inches, excuse me, then here we've got our equation. So to solve this bad boy, we're going to do inverse operations. Now, normally the inverse of multiplying would be dividing, but because I have a fraction, I'm going to multiply by the reciprocal, which means I'd multiply both sides by 5. So off to the side, I'm going to do 288 times 5. So you get a 40. 40 and 4 is 44. 10 and 4 is 14. So I get x equals 1,440. So I would say Allison, oops, forget spelling name, Allison needs 1,440, and we're going to use the same labels, square inches of glass for her project. Okay, and then let's do another one. And again, what I'll do is I'll stop right now, pause it, I'll write it, and then come back and you can do the same. Okay, so Len read 3/4 of a graphic novel over the weekend. Monday, he read 22 more pages. If he has read 220 pages, how many pages does the book have? Okay, so we got this kid. He's reading a book. He read 3/4 of it over the weekend. Monday, he read some more. And then he's read 222 pages. But how many pages does the book have? So there's our question. There's our unknown. So x is the number of pages. Len's book has. Okay, so we took the question and we made it a statement. All right, let's see. Wow, starting off in the first sentence, they already gave us some information. It says he read 3/4 of, oh, there we go again. That's our multiply word. A graphic novel. Ooh. So that is going back to our unknown. So the novel, that's the book, and he read 3/4 of it over the weekend. And then on Monday, he read 22 more pages. So more, actually I'm going to change that. I'm going to go 22 here is a number, and then more tells me in addition to, so there's an adding. And then we understand that he's read 22 pages, or 220 pages. So we got 3 numbers in this one. And then we have our, let's see, purple. I forgot what color I was using. So has read, there's your verb, that's going to be your equal sign. Okay, so here we go. 3/4 of, which by the way, you know you don't need to show the multiplication symbol. 3/4 of the graphic novel was read over the weekend, and then he had 22 pages more. And that he had read, oops, I did a wrong color over here, didn't I? Yep, it should be green. 220 pages. Okay, let's see what to do on this one. Well, first thing we're going to do is to simplify by doing inverse operations with the constants. So we're going to subtract 22 from both sides. And I'm going to continue the problem over here. So that's going to give us 3/4 x is equal to an 8, a lot of renaming going on, a 9, and a 1. And just like in the last problem, we're going to go ahead and multiply by the reciprocal. So I'm going to multiply both sides by, oops, where'd the 5 come from? 4/3. Let's see. 1 plus 9 is 10. 10 plus 8 is 18. 3 can go into 18, so it's divisible. So 4/3 times 3/4 equals 1. That's your inverse property of multiplication. And then 3 goes into 19. Let's see, it goes in 8, 7, 6 times, which is 18, with 1 left over, and into 18 6 times. So then we have 66 times 4. So I'm just going to do that off to the side. And we get 24. We get 24 and 2 is 26. So we get x equals 264. So then we would say Len's book has 264 pages, or Len's book is 264 pages long. Okay? All right. Let's talk. The last two examples are going to be consecutive integer problems, so you can see what those are like. So number 3, we've got, these are short. Find 3 consecutive integers with a sum of -36. Okay? Okay, so consecutive integers. Their definitions are x equals the first number. Consecutive means one right after the other. X plus 1 is the second number. And x plus 2 equals the third number. So you need to define all 3 numbers. Operationally, it tells us they're being added. And we know that the final number is going to be to 36. Okay, so let's go ahead and write out our equation. We'll do it right here. X plus 1 plus x plus 2 is equal to -36. Now, I cannot start doing inverse operations until I have no more than 2 terms per side. So I look for like terms, and I have those 3x's plus 2 is equal to -36. Now I'm ready to do inverse or operations that will undo. Excuse me. So I'm going to go ahead and subtract 2 from both sides. And I get, oh, I did add that wrong. And I'm like, wait a second, that's going to give me an even number. That's not going to work. So that's what happens. Your brain, it starts telling you, wait a second, that doesn't look right. And that's what it did to me. It's also telling me I should go to bed. So when I finish this, I will. So subtract 3 from both sides. And we get 3x is equal to -39. And then we divide both sides by 3, and we get x equals -13. So the first number is -13. If I take -13 and add 1 to it, I get -12. If I take -13 and add 2 to it, I get -11. So I would say the 3 consecutive integers are -13, -12, and -11. Okay, and then one more. find 3 consecutive odd integers with a sum of 75. Okay. So again, we have consecutive and it mentions odd. Now, I'm going to tell you what is the most common mistake that you need to avoid. Remember, odds is not counting by odds. They're the odd numbers. So to get from one to another is counting by twos. So I don't go from 1 to 3 by counting by 1. But that's the pattern, there I go, that I see all the time from kids. It's not x and x plus 1 and x plus 3. No, it's x and x plus 2 and x plus 4. Now, the interesting thing is, if you try to solve this problem and you had the wrong definitions for your variables, you're not going to get 3 odd numbers. And for whatever reason, kids don't look at their answers and ask if they're reasonable. You got to check, okay? We do have a sum, which actually tells me 2 things. It tells me I'm adding, and it tells me equals. And then we do have an extra number, 75. So, here's my problem. The sum of x and x plus 2 and x plus 4 is equal to 75. So we look for like terms, and I've got different kinds this time. I've got 3 x's, and then I have plus, and then I have some constants, which again, I was not super good at getting those last time. I'll get them right this time. There we go. And that equals 75. So we go ahead and subtract the inverse, 6 from both sides, and that leaves me with 3x equals 69. And then we divide both sides by 3, and we get x equals 23. So the first number is 23. So over here, when I added 2, I get 25. And then when I add 4 to 23, I get 27. So my numbers are 23, 25, and 27. They're all odds. They're in consecutive order. So the answer would be the 3 consecutive integers are 23, 25. Ooh, that's a terrible 25. And 27. All right, and that's it, guys. So good luck with this. We'll talk to you later. Bye-bye now.